In Chapter 7, we'll be able to show, under certain assumptions, that the velocity v of t of a falling raindrop at time t is v of t, which is equal to v to the power of star times 1 minus e to the power of negative g times t divided by v to the power of star. So where g is the acceleration due to gravity and v raised to the star is the terminal velocity of the raindrop. In part A, we want to find the limit as t approaches infinity of the function v of t. So here we want to find the limit as t approaches infinity of the function v of t. Well, we know that the function v of t is equal to v to the power of star times 1 minus e to the power of negative g times t divided by v to the power of star. And so now let's go ahead and evaluate it according to t approaching infinity. So we're going to have v to the power of star times 1 minus e. Well, t is going to be as it is approaching infinity, so this is going to become e to the infinity. And so therefore, this becomes the terminal velocity times 1 minus e to the infinity is 0. So we get this terminal velocity as our result. Okay, now we want to be able to graph v of t if the terminal velocity is 1 meters per second and gravity is 9.8 meters per second squared. How long does it take for the velocity of the raindrop to reach 99% of its terminal velocity? Well, let's recall what that function looks like. So for the first part, we're going to have two different functions. The first function is where we see that the terminal velocity is 1 meters per second and gravity is 9.8 meters per second squared. So what that means is we have, plug it into this formula, that means that v of t is going to equal 1 times 1 minus e to the negative 9.8 t divided by 1, which then equals 1 minus e to the negative 9.8 t. So therefore, that is our first function. Now, the second function is asking us, how long does it take for the velocity of the raindrop to reach 99% of the terminal velocity? So that means we have v of t, which is going to equal 99% of the terminal velocity. Well, this becomes 0.99 times 1, which is equal to 0.99. So now let's go ahead and graph this on Desmos. So what we want to do is we want to graph these two functions on Desmos to determine where do they intersect. So the first function here is going to be 1 minus e to the power of negative 9.8x. And then our second function is going to be y, which is equal to 0.99. And so therefore, here is our graph and what that looks like. Okay, so you can see here that this is the point of intersection. So let's go ahead and copy that. So recall that we can see here that t represents the horizontal axis, and then v of t is the vertical axis. So that means that t equals 0.47, and then the output is 0.99, which is what we got here. So the point of intersection tells us that t is equal to 0.47 seconds. So again, to answer the question, how long does it take for the velocity of the raindrop to reach 99% of its terminal velocity? Well, we can see here that it takes 0.47 seconds to reach 99% of its terminal velocity.